Hello, welcome to our video about sine, cosine, and tangent ratios. This is some brand new information that we are going to be dealing with today. So the sine, cosine, and tangent ratios are names of ratios in triangles. They deal with the sides based on an angle measure. So let's get a picture, and if I were you, I would draw this picture in your notes. Okay, so we just have a right triangle. It's very important that you realize that this only works for right triangles. And let's label it A, B, C. And then the sides, the side opposite of A, we'll label little a. And the side opposite of B, we'll label little b. And the side opposite of C, we'll label little c. So the sine, cosine, and tangent are ratios of sides. It's a comparison of two sides in a triangle. So for our purposes right now, let's look at angle A. Okay. First, we'll talk about the sine. Sine, we abbreviate SIN. So we would say the sine A. You would write the sine A. You would say it sine of A. The ratio that gives you the sine of A is the opposite side over the hypotenuse. And remember, the hypotenuse is the longest side. So the opposite side of A is A. The hypotenuse is C. So you would make the fraction A over C. And that would be your sine ratio. Your cosine ratio you write it as cos, C-O-A, or C-O-S, of angle A. So you would say it cosine of A. It is the ratio of the adjacent side and the hypotenuse. So adjacent just means next to. So the adjacent side to angle A is B. Yes, I do realize that C is also adjacent to A, but C is the hypotenuse. So you can't have the same number twice. So you have the adjacent over the hypotenuse. Or in our picture, it would be side B over side C. And then the final ratio is tangent. The tangent ratio, we abbreviate it TAN. So we would say tan A if we're talking about angle A, or the tangent of A. Is the opposite side over the adjacent side. So if you're looking at your triangle and you're looking at angle A, because that's what it's telling you, look at angle A. The opposite side of A is A. The adjacent side of A is B, again, because C is the hypotenuse. And that would be your ratio. Now, this is a lot to remember. There is a very popular acronym that's out there. So if you take the first letter, S, C, and T, so the sine ratio deals with the opposite over the hypotenuse. The cosine ratio is the adjacent over the hypotenuse. And then the tangent ratio is the opposite over the adjacent. when we write it all into like a word, you get the phrase SOHCAHTOA, which is how a lot of people like to remember it. Let's look at a couple examples. Today we're just going to focus on making the ratios themselves. So let's draw a right triangle. Again, I'm freehanding this right triangle. So we are going to not be drawn very well to scale. So if I look at this triangle, let's find a couple ratios. Let's say I want to know the sine of angle y, the sine of angle x. How about the cosine of x, and we'll do the tangent of y. Okay, so again, this tells me which ratio. This tells me the angle that I'm referencing for the triangle. So the first problem says look at angle y. Okay, look at angle y. I want the sine. Sine is opposite over hypotenuse. So the opposite side of y is 40. The hypotenuse of the whole triangle is 50. So this is 40 over 50. And then you would reduce that fraction, which is just 4/5. Now, the next one, if we go down, it's talking about the sine of x. So this time we're still doing opposite over hypotenuse, but now we're changing the angle that we're looking at. So the sine of x, I'm looking here, opposite is 30. And the hypotenuse of the triangle is still 50. So this is 30 over 50, which is 3/5. Let's look at our next problem. Now we're changing trig ratios. This says the cosine of x. So again, cosine is adjacent over hypotenuse, adjacent over hypotenuse. And I'm looking at angle x. Looking at angle x, I want my adjacent side and my hypotenuse. Adjacent is your next to side. So that's 40 over 50, which reduces to be 4/5. You'll notice that these two fractions are the same. It's going to happen a lot, especially if you're finding multiple trig ratios in the same triangle. There's only a limited number of angles and sides and numbers you can actually use. This last one says tangent of y. So that means we're changing our perspective and we're changing our ratio. Tangent is opposite over adjacent. And I'm looking at angle y. So I'm back over here looking at angle y. The opposite side of angle y is 40. The adjacent side to y is 30. So this is 40 over 30, which is 4/3. Let's look at a triangle that has a radical in it. And we'll call this triangle QRS. Typically, for your purposes, you're only going to be finding the sine, cosine, and tangent of the acute angles. You're not ever really going to be working with the right angles for now. You will in the future, but for the purposes of our course, you're focusing on the acute angles. So in this case, it's going to be Q and R. I'm going to go ahead and write down my acronym. I would encourage you every single time to write down your acronym, because it's going to make life easier for you. So let's find these ratios. So the sine of Q, first off, sine is opposite over hypotenuse, and I am looking at angle Q. So here's angle Q. The opposite side of angle Q is 7. So this is going to equal 7 over the hypotenuse of the whole triangle, which is the longest side, which is the side opposite the 90. I'm just going to go ahead and label that hypotenuse. It's going to be the same every time I need the hypotenuse, is the square root of 65. Remember, you are a good math student, and good math students always rationalize your denominator. I will expect that you do that often, and I will expect that you reduce your fraction if possible. You will lose points if you do not do it. Now, remember, when you rationalize your denominator, you multiply the top and the bottom by the square root of 65, because that's the root on the bottom. Now, you can go ahead and grab your calculator and multiply 65 by 65, but at this point, you should realize that the square root of 65 times the square root of 65 is just 65, and that's your answer. Looks weird, but that's fine. That's how we want to see it. Let's look again. This time we want the cosine. Cosine is adjacent over hypotenuse. And I'm looking at angle R this time. So here's angle R. I want the adjacent side to R, not the hypotenuse, because that's the square root of 65. The adjacent side to R is 7. And then I have the square root of 65 on the denominator. Interesting that that's the same as the previous answer, which is very common and totally correct, because you're using the same numbers, you're just looking at it from a different perspective. The sine of Q and the cosine of R are going to be the same because they're in the same triangle. Now let's look at tangent of Q and tangent of R. Tangent of Q and tangent of R aren't going to be the same ratio, but they're going to be close. Remember, tangent is opposite over adjacent. So looking at angle Q, here's angle Q. The opposite side of Q is 7. The adjacent side to Q is 4. Remember, the adjacent side to Q, not the hypotenuse, because the hypotenuse is always the hypotenuse. It can't be the adjacent side. So the tangent of Q is 7 over 4. Now let's look at angle R. It still wants me to find the tangent this time, opposite over adjacent, looking at R. So you're looking at the triangle from a different perspective. The opposite side of R is 4. The adjacent side of R is 7. So if you notice, these are the same thing, same numbers, they're just reciprocals of each other. Again, totally correct, it's not wrong. Again, that happens because you're looking at the same triangle, you're just looking at it from a different perspective. All right, take some time, do some practice problems, and let me know if you have questions.